Assalamu alaikum. My name is Muhammad Haris, and today I have to explain these questions. So, let me share my screen. So, basically, the question is sliding window median. The median is the middle value in the ordered integer list. If the size of the list is even, there's no middle values, so the median is the mean of two middle values. So, if the array is 2, 3, 4, the median is 3. If the array is 1, 2, 3, 4, the values will be uh, 2, 3 divided by 2. So if you are going to integer array nums and integer k, there is sliding window of size k which is moving from the left the array to the right of the array. You can see the k numbers in the window each time the sliding window moves right by one position. Return the median array for each window in the original way in its answers within 10 to the power 5 of the actual value. For example, if we have given input is equal to 1, 3, this, what we have to do is we have to see that what is the value of k. That will be the window size or will be the subset in an array. For example, if k is equal to 3, it means that first we have to find the median of these numbers 1, 3 and minus 1. Then we have to find the median of these numbers and then these and likewise, and then we have to add those medians into a list like this. So for example, 1, 3 minus 1 is median is 1, 3 minus 1 minus 3 is minus 1, likewise. And example 2 is also the same. Window size is 3. We have to find medians of all the window sizes and then add those medians into a list. So constraints are that the value of k is greater than equal to 1 and less than equal to less than equal to 10 to power 5. And nums, the array length also is equal to greater than equal to k and less than equal to 10 to power 5. Greater than equal to 1 and less than equal to 10 to the power 5 as well. And the values in the arrays must be greater than equal to 2 minus 2 to the power 31 less than equal to 2 to the power 31 minus 1. So I think so. So what I did is basically I implemented two heap pattern. So let me notate it first. So basically, let's take this example. For example, so basically what I did is this is my uh, min and this is my max. Firstly, what I did is I put my first number, which is 1 in this case, into my max. After that, what I did is that I checked the length of these two. If length of max is greater than equal to length of min plus 1, which is in this case is not min plus 1, both are conditions doesn't satisfy. So, and other condition is these conditions are used for balancing. Firstly, I put numbers into my add my numbers into the min and two heaps, min and max, and then what I do is I balance the min and max heap. So I add the number and then I check the condition that if you can see it here as well, if the length of uh, max heap is greater than equal to length of min heap plus one. If yes, if we have to push that max number to min. In this case, it doesn't follow. Likewise, if length of max heap is less than length of min heap, we have to push min heap number to max heap. So in this case, it doesn't follow. So what I do next is I take the next number and check that if that three number we are adding, if it is greater than to max, if it is greater than, so uh, it means that we have to put that number three into min, and then check the balancing equation. Balancing equation does not satisfy in this case as well. So we took our next number. If our next number is greater than 1, no, it's not, minus 1 is not greater than 1. So what we do is we put that minus 1 into max. After that, we again check for balancing. So as you can see, it doesn't also satisfy the balancing as well, because length length of max is 2 and length of max min heap is 1 plus 1, which is also equal to 2. So it doesn't satisfy as well. Also the if condition that if it is less than min heap, max heap. In this case, max is 2 and min heap is 1. So it doesn't satisfy also. So what I do is when I get to when I get when I complete my first window size, which is 3 in this case, 1 3 minus 1. When I add my numbers into two heaps, and then uh, I balance the heaps, balance the numbers in the heaps. So what I do is next I this condition will follow. It means that if I is 2, in this case I is 0 1 2, 2 is less than greater than equal to k minus 1, k is 3, so k minus 1 will be 2. If 2 is greater than equal to 2, greater or equal to 2, we have to take median of the number. And how we will take median of the number? By simply what we'll do is we will first check that if our length are equal to each other. For example, if they are even numbers in the window size. For example, if the size of was 4, it means that uh, we would have two numbers in min and two numbers in max. But in this case, our there's odd numbers. So in our odd numbers, max length will always be greater than min length. So max length will be 2 and min length will be 1. So what we do is we firstly check that if our length is, or if it is even window size, we will do this. If it is odd, it means that we have to take the top number as our median. In this case, 1. It is correct. So our median will be 1. So what we do is we take the median and store it into this list which we created in this statement. Why this is a statement? So it will be given to this. And likewise what we do is after when our I will be from I treat from 2 to 3, then this condition will follow. This condition will satisfy. In this condition what we do is we remove the uh, top number. We remove the top number in our max array. So numbers I minus k, which means that uh, 3 minus 3, it means that we have to check that number. 3 minus 3 is equal to num0. Num0 is 1. Num0 will be passed in this remove function. Uh, we will check that if num0 is greater than equal to max heap 0, max heap 0. So notice not. So what we do is we remove the uh, max heap top function, which is in this case is 1. Remove that by simply calling the remove function, which is used to delete the numbers in the heap. And then we use this statement. What this statement is do is this statement converts a regular list to a heap. If new number comes, it adjusts its position. It means that now our array would look our window size would look like 3 minus 1, because one is deleted from that window size. So for example, if we had 1 3 and minus 1, like uh, let's draw it a tree. If our 1 is deleted, it means that we have to adjust the next number which is coming. So what we do is we use heapify function to adjust the next number which is coming to a heap. So what it do is it basically adjusts it all, balances uh, the tree, heap tree. So yeah, uh, let's go to the code again. We took the medians number of we took the answer list, which will be equal to length of nums minus k. It means that the output will be length of the output will be equal to this number position. We take a number of nuns in our the nums medians position. So medians, the length of the median will be equal to length of the output. It is basically none right now. we take a j is equal to 0. We iterate from every number in the nums array, and then likewise we are adding the numbers, adding it, and after adding it we also balance the, after adding it we check the conditions as I explained earlier, and then I balance the equation, uh, balance the uh, balance the heap, max and heap. After balancing it, I also, in balancing question, I've also checked that if length of the heap is greater than equal to length of main plus one, and likewise if length of max heap is less than main heap, push it into max. So after that, when this condition, when I will be equal to 2, this condition will follow. In this condition, what it do is it takes a median, one median out of a subtree. In this case, 1 minus 1 will be our subtree, and we have to take the median of the sorry, not subtree, window size. So what we do is we check that if it is even, if length of max heap is equal to length of min heap, what we do is we take the top two numbers in max and min heap and divide it by 2. So it will be a median. If it is window size, it means that the length, there will be two numbers in max heap and one number in min heap. So what we do is we uh, take the top number in the max heap, which will be medium in every case. So after that, this condition satisfied, we put that median into our list of medians. So uh, it means that everything will be none except the first index in our in our in this case. So after that, I will be I will become from 2 to 3, and this condition will execute this statement. In this statement, remove function is used. As I told, that remove function check is that if it checks that if the number which you are checking is greater than in the top greater than the top value of the max heap. If it is greater than top value, we will remove the min heap number. If it doesn't, it means that we have to remove the max heap top number. We have to remove either min heap top number or either remove max heap top number. So in this case, one was not greater than 1. So what we do is we remove the top number in the max heap. Then heap5 basically, as I told, that it converts list into a heap. So I think so we are done. Adding function, balancing function, find medium, remove number. So also I forgot to tell that after that, what we have to do is also have to balance the heap as well. So balancing simple, using calling the simple balancing function. I will check that if it also works without it. Yes, it does work. No, it doesn't. So what we have to do is we have to take the balancing. So what I have to do is I have to unprint these numbers. Yes, it does work. It is simulated, and as you can see, it has also very time efficient. So basically, the time complexity will be in this case is O of n, because of the fact that it is iterating to through every number in a node. So that's why also I've used for function as well. So our time complexity will be O of n, but in general our time complexity in heap is log of n, but in this case it is O of n because of the window size case, and our space complexity will be uh, I guess so. Our space complexity is O of n as well because we created uh, another array, which is this, which will be consisting of none numbers in the list firstly, and after that we will add a number, add the medians into the numbers. So okay. So yes, let's go to question number 2. So basically, question is generate parentheses. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. For example, if n is 3, it means that the number of open parentheses and closed parentheses will be equal to n. If n is 3, it means that there will be 3 open parentheses and there will be 3 closed parentheses in every combinations. Uh, So if an example 2, if n is equal to 1, it means that there will be one closed parenthesis and one open parenthesis, and n will be equal to less than greater than equal to 1 and less than equal to 8. So basically, what we have to do is, let's take the example number 1. So firstly, what we do is I have used the backtrack approach, recursion approach. So basically, first we do is we add our open parenthesis, and then we have to check two conditions in this problem. First, we have to check that if our open parenthesis is less than n. If it is less than n, then we will add open parenthesis. If our open parenthesis is less than n, and if our close parenthesis is less than open, then we have to add close. Otherwise, we have to add open in the first case. So basically, first we do is we first add open parenthesis and then check the condition, these two conditions, condition number one and condition number 2. If both the conditions satisfy, first we add open again, and then our check our second condition. It also says that it also satisfied, and we add open and close again. After that, we check that if our new subset, if it satisfies the condition, yes, it is satisfied the condition. So we add both the conditions in this subset as well. So this we add like that, and that new subset will be 2 open and a close. Likewise, in this case, the second condition does not follow because close is equal to open. So only first condition will be implemented. So first condition is we add the open parenthesis. And likewise, like fourth, we will check these two conditions and carry on with our implementation. So it is basically it's all doing backtracking. So um, at the end, what we'll get it we will get strings at the end. After that, what we do is uh, uh, we'll get a list. After that, we will convert that list into strings and then add that strings into our result list. So basically, what we'll get at the end is lists of open parentheses and like that. But what we do is we will convert those lists into strings and then add that strings to a list, which will be called result at the end. So let's look at the code implementation. So firstly, we do is we create a stack, and then we create a result list. After that, we implemented a backtrack function in which we take a open and a uh, closed and open variable. These open and close will be zero firstly because there's no open and close parenthesis at the start. After that, this will be our base function base. Uh, so what we do is in this basically if open is equal to so basically if open is equal to close equal to n, it means that if we got three open, three close, then what we'll get is we'll get a subset which will be returned as a string. So that and likewise, if it is like this, one open, one close, one open, one close, one open, one close, it is also acceptable. It will return the string. Likewise, so it will check the condition for that. After that, we will check is if open n, as I discussed, if open n is less than n, if for example if open parenthesis is less than the number which is given, then we add open parenthesis. After that, we give the we call the recursion function and append that open n plus 1 because we have add open parenthesis, and we will return the close n as as it was. So likewise, then I will pop the pop the character which is in the stack, which is this. Then after that, the second condition which I discussed earlier, that if close as n is less than open n, because as you can see in this, I have used this condition because of the fact that if, as you can see, that it is not acceptable. If we have closed first and then uh, sorry closed first and then open, it is not acceptable. Only if we had open and close, then it is acceptable. So that's why I've used this condition to satisfy uh, this logic. So close and less than open, and yes, we will append that into stack. Then I will append that. Then I call it this recursion function, and I pass the open as it was and close. Incremented it by one because we have we have append the close parenthesis. That's why. So after that, likewise, I call a recursion function. Then I pop the character which I recently added into the stack. After that, I simply call the backtrack function, gives a 0 0, and then I return the result variable result in which we would have uh, strings of open parenthesis and open and back parenthesis. So let's check the result. If it yes, it does passes. So I've used the print function. That's why it is printing. Yes, it does passes, and let's check the code. Yes, it is also passed. So like I discussed, the edge case in this problem will be n is equal to 1. If n is equal to 1, if it means that there will be only one open parenthesis and one closed parenthesis, so this would be a edge case. And other case would be if uh, sorry, the time complexity of this code will be O of n because of the fact that we are iterating through every character. That's why it would be O of n, and space complexity would be O of n as well. So T would be O of n as well, and space will be O of n as well. So uh, so thank you for watching, and that's it. Okay, Allah Hafiz.